Today, we dive into the world of Git, a version control system focusing on the initialization process. John, could you explain what Git init does?
Absolutely. The git init command essentially initializes a new Git repository in your directory. This creates a Git folder which contains all the necessary repository files. It's akin to setting a blank canvas for your project history.
That's a great analogy. But why is such initialization crucial for version control in software development?
Without initialization, there's no local repository to track changes. Similar to starting a new journal without the first page, unwelcome complications arise. Yet, some argue tools like Dropbox can substitute Git, though they lack collaborative coherence.
Indeed, while Dropbox has its uses, the robust control Git offers is unmatched. As we evolve, do you foresee any shifts in how initialization setups might integrate with other platforms?
Integration with cloud services like GitHub is becoming seamless. As AI grows, we might see auto-initializations optimized for varying project types, facilitating a more intuitive start for developers.
Let's transition to file management using Git. How does the command, git add, come into play in project workflows?
Git add stages your changes. Consider it as adding items to a shopping cart before proceeding to the checkout with a commit. It allows you to selectively decide what changes to track.
Given its selective nature, is there risk if used incorrectly by new developers?
Indeed, staging inappropriate files, especially sensitive information, can lead to vulnerabilities. One must practice cautious selection using git ignore wisely. There's debate on whether live validation tools should assist beginners.
With ongoing debates, have there been recent innovations addressing such potential oversights?
Virtual environments now test compliance automatically before changes are staged, minimizing beginner errors. Future developments may include AI-guided suggestions akin to spell check before Git additions.
Let's delve into the heart of version control, the Git commit feature. Why is committing our code vitally important?
Committing is like marking a historical moment for your code. It logs changes, allowing you to track development like a diary entry, creating reliable restore points.
Some say commit messages can be trivial, but why then emphasize detail?
Vague messages can mislead future developers. A detailed commit, akin to comprehensive annotation on a document, conveys clear change intent. Critiques imply verbosity can clutter logs, yet clarity trumps conciseness for team synergy.
Absolutely, the balance is key. As we adopt more collaborative tools, is there room for commit automation?
With AI inferencing behavior patterns, auto-generating initial commit messages may aid consistency. However, human context remains indispensable for nuanced decisions, preventing potential oversights.
To wrap it up, can you guide us through the process of pushing code to a remote repository and its importance?
Pushing transfers local commits to your remote repository like publishing a book. The git push command ensures local work is safeguarded externally, pivotal for teamwork and backup.
What about concerns regarding conflicts or push failures?
These issues arise when local changes deviate from the remote state, requiring merging strategies. Critics argue constant pushes inflate repository size, but disciplined practices mitigate such risks.
As Git progresses, what do you foresee in terms of enhancing this process?
I anticipate advanced conflict resolution tools with machine learning, predicting and prescribing potential merge paths before conflicts hinder a project. This could revolutionize collaborative coding efforts.